This is Steve from the field engineering team at Wallaroo, and today we're going to be taking a look at how we can package models in Wallaroo with OpenVINO acceleration for x86 CPUs and GPUs from Intel. First, we're going to import our Wallaroo SDK, create a client and authenticate with our Wallaroo instance, and set our workspace as we normally do. From here, we can take a look at our example, which is going to be deploying an FRCNN object detector in a retail setting. When I call upload model to register my model artifact with Wallaroo, I can specify that I want to use OpenVINO for the acceleration at packaging time. And as you can see here, I specify that my framework is Onyx because we're working with an Onyx model, but OpenVINO acceleration is available for all of our supported frameworks, including PyTorch, TensorFlow, XGBoost, and even arbitrary Python code, among others. Once I run this line, Wallaroo will take care of the packaging for me, specifically for OpenVINO acceleration. From there, I can specify the hardware I want to power this deployment, in this case 2 of our x86 Intel CPUs and 2 gigs of memory. Then I can build my pipeline as normal and deploy it out. A few seconds later, my deployment process is complete and I can go ahead and test it out on our sample image. I can see the outputs returned by the model, and I can go ahead and plot them to make sure they look as expected. If I'm happy with those results, I have my external URL that has been automatically generated that I can start to use to integrate with any other services that are going to rely on this model. If I want to extend this deployment to work on edge devices, I can run 2 additional lines to publish my pipeline and then register specific edge devices. This will make this entire process standalone, and as we can see here, we'll generate a Docker container specifically packaged with my OpenVINO acceleration in mind, as well as an artifact for my pipeline that I can go ahead and run at the edge with this Docker run command that I can copy and paste. Finally, if I want to use OpenVINO acceleration with Intel GPUs, I can take care of that the same way. I don't need to do anything different when packaging my model. I just need to add the .gpus option to my deployment configuration and redeploy. Moving over to our Wallaroo Operations Center, we can see this pipeline alongside any others that I might have. And if I click on it, I can see things like the URL to access it at, any previous versions of the pipeline, and if they've been published, the status of the pipeline, and the configuration of my deployment, including, as we see here, our OpenVINO acceleration. And if I switch over to a version that's been running for just a little bit longer, I can see that I can still take full advantage of the centralized logging, observability, and automatic drift detection that Wallaroo offers with my OpenVINO accelerated models alongside any other models that I might have. From a performance perspective, when looking at a sample ResNet 50 model similar to the one we saw today, we were able to see 2x faster inference time when using Wallaroo with the OpenVINO optimizations compared to Wallaroo alone on the same hardware configuration of 16 Intel CPUs. When looking at GPUs with a sample YOLO V8N model, we see a similar trend. Using Wallaroo with OpenVINO acceleration on 2 different classes of Intel GPUs, we were able to see a 10x faster inference time compared to Wallaroo with similar optimizations for NVIDIA CUDA. And so whether you're interested in computer vision or other use cases, and whether you're planning on using CPUs or GPUs to power your inference, OpenVINO offers a powerful way to accelerate your ML pipelines. And by using Wallaroo, I can very easily take advantage of that OpenVINO acceleration when packaging my models.